The U.S. Future Long-Range Assault Aircraft FLRAA, History, Present and Future. Introduction. The Future Long-Range Assault Aircraft FLRAA program represents a significant leap forward in U.S. Army aviation aimed at providing advanced capabilities to replace the aging Sikorsky UH-60 Black Hawk fleet. Initiated in 2019, the FLRAA project is part of the larger Future Vertical Lift FVL initiative, which seeks to enhance the Army's aerial maneuverability and operational effectiveness in modern combat environments. This report delves into the history, current status, and future implications of the FLRAA program. Historical background. The FLRAA program began in earnest when the U.S. Army issued a Request for Information (RFI) in April 2019 seeking to identify manufacturers interested in developing a next-generation assault aircraft. The need for a replacement for the Black Hawk, which has been in service since 1979, became increasingly urgent due to the aircraft's aging systems and limited operational capabilities. In December 2022, the Army awarded the FLRAA contract to Bell Textron for its V-280 Valor tiltrotor design. The V-280 is a significant advancement over traditional rotorcraft, capable of reaching cruise speeds of 280 knots and a maximum speed of 305 knots with a ferry range of 2,100 nautical miles, essentially doubling the speed and range of the UH-60M Black Hawk. This capability is expected to enhance the Army's ability to conduct long-range high-speed operations. Key milestones and developments. 2019, the U.S. Army issued an RFI for the FLRAA program. 2022, Bell Textron was selected as the contractor for the FLRAA program. 2024, the FLRAA project achieved Milestone B. Transitioning to the Engineering and Manufacturing Development (EMD) phase. This milestone allowed for the construction of 6 prototypes and the initiation of low-rate initial production (LRIP). 2026, the first flight of the FLRAA is scheduled to take place. 2028, low-rate initial production is expected to commence. 2030, the FLRAA is projected to enter operational service. Design goals and specifications. The design goals for the FLRAA are ambitious and focused on enhancing the Army's operational capabilities. Key specifications include: combat radius, a minimum of 200 nautical miles with a desired increase to 300 nautical miles. Speed, a maximum cruise speed of 280 knots with operational capabilities expected to exceed that of current helicopters. Payload, the aircraft is designed to carry a significant payload with the ability to transport troops and equipment efficiently. These specifications aim to deliver a platform that can execute complex missions including troop transport, medical evacuation, and logistical support, while maintaining a high degree of agility and survivability in various combat scenarios. Operational capabilities. The FLRAA is expected to revolutionize how the Army conducts air assaults and troop movements. Its capabilities will enable the Army to conduct operations over longer distances with increased speed and efficiency. For example, the Army is exploring the potential to transport a Brigade Combat Team over 500 miles during nighttime operations, a task that would be impractical with existing platforms. In addition to its primary assault capabilities, the FLRAA will also serve roles in medical evacuation and logistical support, providing the Army with a versatile tool for a range of operations. Training and cultural transformation. As the Army integrates the FLRAA into its operational framework, significant training and cultural changes will be necessary. Army pilots will need to adapt to the unique flight characteristics of a tiltrotor aircraft, which operates at higher speeds and altitudes than traditional helicopters. This includes developing new tactics, techniques, and procedures tailored to the FLRAA's capabilities. To facilitate this transition, the Army is collaborating with Marine Corps aviators who have experience with the V-22 Osprey, leveraging their insights to develop training programs that will prepare pilots for the operational environment of FLRAA. Digital engineering and development approach. A notable aspect of the FLRAA program is its embrace of digital engineering practices. This approach allows for real-time collaboration between the Army and Bell Textron, facilitating quicker iterations and adjustments to the aircraft's design. The use of digital models enables the identification of potential issues early in the development process, thereby streamlining the path from design to production. The Army has committed to delivering virtual prototypes to support training and operational planning ahead of the aircraft's physical arrival. This innovative approach is expected to enhance familiarity with the FLRAA and inform the development of operational concepts. Future implications and strategic importance. The successful deployment of the FLRAA will have far-reaching implications for U.S. Army operations. Its capabilities will not only enhance the Army's ability to conduct air assaults but also improve overall battlefield maneuverability and logistical support. As the Army prepares for future conflicts, the FLRAA will play a critical role in maintaining a technological edge over adversaries. Furthermore, the FLRAA program underscores the Army's commitment to modernizing its aviation fleet and adapting to the changing nature of warfare. As military operations increasingly rely on speed, agility, and precision, the FLRAA will be instrumental in shaping the future of U.S. Army aviation. Conclusion. The Future Long-Range Assault Aircraft project represents a pivotal advancement in U.S. Army aviation, set to replace the aging Black Hawk fleet and redefine air assault capabilities. With its combination of speed, range, and versatility, the FLRAA is poised to transform how the Army conducts operations, ensuring that it remains ready to meet the challenges of future conflicts. As the program progresses through its development phases, the Army's commitment to integrating advanced technologies and fostering a culture of innovation will be crucial to its success. The FLRAA is not just an aircraft, it is a symbol of the Army's forward-looking approach to modern warfare, ensuring that it is prepared for whatever challenges lie ahead. The Future Long-Range Assault Aircraft FLRAA program is a pivotal initiative by the United States Army aimed at developing a next-generation helicopter intended to replace the aging Sikorsky UH-60 Black Hawk. This project is part of the broader Future Vertical Lift FVL program, which aims to modernize the Army's aviation capabilities significantly. While the information presented about FLRAA may seem straightforward, there are several counterintuitive aspects that can be identified. Counterintuitive insights. 1. Speed versus traditional tactics. The FLRAA is designed to operate at significantly higher speeds than the Black Hawk, with a cruise speed of 280 knots compared to the Black Hawk's typical operational speed of around 100 knots. This drastic increase in speed will require a fundamental shift in tactics. For instance, pilots who are accustomed to flying at low altitudes and slow speeds will need to adapt to flying at higher altitudes and faster speeds. This shift may initially seem beneficial, but it could lead to challenges in training and operational execution as crews learn to employ new tactics for high-speed operations. 2. Cultural shift in Army aviation. The introduction of the FLRAA, particularly its tiltrotor design, signifies a significant cultural shift in Army aviation. Historically, Army aviation has been predominantly helicopter-centric, with a focus on low-speed, low-altitude flying. The FLRAA will necessitate a transformation in mindset and operational training akin to what the Marine Corps experienced with the V-280 Osprey. This transition may create resistance among some personnel who are accustomed to traditional helicopter operations, leading to a period of adjustment that could temporarily impact operational effectiveness. 3. Perception versus reality of technological advancements. The FLRAA program is lauded for its technological advancements, particularly in digital engineering and design processes. However, while these innovations aim to streamline development and enhance performance, they may also lead to overconfidence in the system's reliability. Past experiences with advanced systems like the V-280 Osprey have shown that technological innovations do not always equate to operational success. The Army must remain vigilant to avoid pitfalls associated with relying too heavily on new technologies without addressing potential mechanical issues and operational challenges. 4. Increased complexity leading to new risks. The advanced capabilities of the FLRAA, such as its speed and range, will lead to more complex operational scenarios. While it may allow for more ambitious missions such as moving an entire brigade combat team behind enemy lines, it also introduces new risks. The operational environment will become more challenging as units must execute rapid maneuvers over greater distances, potentially exposing them to new threats and requiring a re-evaluation of support and logistics strategies. 5. Potential for overestimation of capabilities. The anticipated capabilities of the FLRAA, including its ability to operate in high-threat environments and perform complex missions, may lead to an overestimation of what the aircraft can achieve in practice. While simulations and preliminary tests show promising results, real-world conditions often introduce variables that can affect performance. The Army must manage expectations and ensure that realistic assessments of the FLRAA's operational capabilities are conducted throughout its development and deployment. 6. Modularity versus standardization dilemma. The FLRAA program emphasizes modularity and adaptability, which can be seen as a strength. However, this approach may also complicate standardization efforts across the fleet. Different configurations and capabilities could lead to logistical challenges and maintenance difficulties, as support crews must be trained and equipped to handle a wider variety of systems. This reality could counterintuitively slow down the overall operational readiness of the Army's aviation assets. 7. Operational dependence on virtual prototypes. The Army's decision to utilize virtual prototypes as a significant part of the FLRAA development process indicates a shift towards advanced simulation techniques. While this can accelerate development and reduce costs, it also creates a dependency on simulations that may not fully capture the complexities of real-world operations. This reliance could lead to gaps in training and operational preparedness if not balanced with practical, hands-on experience. 8. Feedback mechanism and soldier involvement. The Army's involvement of soldiers in the design and testing phases is presented as a progressive approach to ensure the FLRAA meets operational needs. However, this reliance on soldier feedback could inadvertently create bias in the design process. Soldiers may favor designs based on comfort and usability rather than on tactical effectiveness, potentially leading to compromises that impact the aircraft's overall mission capability. In conclusion, while the FLRAA program represents a significant leap forward in Army aviation capabilities, its implementation is fraught with complexities and challenges that may not be immediately apparent. The interplay between advanced technology, cultural shifts, operational realities, and soldier involvement will necessitate careful navigation to ensure the program's success. Addressing these counterintuitive insights will be crucial as the Army prepares to introduce the FLRAA into its operational framework. The Future Long-Range Assault Aircraft FLRAA program is a critical initiative aimed at revolutionizing U.S. Army aviation capabilities. While the report outlines significant milestones and technical specifications, several aspects may be overlooked by the general audience, yet they hold substantial significance for the future of military operations. 1. Digital engineering as a game changer. One of the most noteworthy elements of the FLRAA program is its reliance on digital engineering. This approach is not just a technological upgrade. It represents a paradigm shift in how military aircraft are designed, developed, and tested. Traditionally, the military procurement process has been criticized for its lengthy timelines and cumbersome iterations. However, the FLRAA's born digital approach enables real-time collaboration between the U.S. Army and Bell Textron. This methodology allows for immediate feedback, rapid prototyping, and the ability to catch design flaws early in the development process. Significance: this shift to digital engineering could drastically reduce development time and costs, allowing for more adaptive and responsive military capabilities. It sets a precedent for future defense projects, emphasizing a need for agility in an era of fast-evolving threats. 2. Cultural transformation within Army aviation. The introduction of FLRAA necessitates a transformation in the culture and operational mindset of Army aviators. Historically, Army helicopter pilots have trained to operate at lower speeds and altitudes, utilizing visual navigation. The FLRAA's capabilities, cruising at speeds of 280 knots and operating at higher altitudes, will require a complete retraining of pilots and crews. Significance: this cultural shift is crucial for maximizing the potential of FLRAA and could lead to enhanced operational effectiveness. The collaboration with Marine Corps aviators who have experience with tiltrotor technology is a strategic move that facilitates knowledge transfer and accelerates adaptation. 3. Implications for tactical operations. The FLRAA's design not only enhances speed and range but also transforms tactical operations. The Army is already experimenting with new operational concepts such as large-scale long-range air assaults, which aim to deliver troops behind enemy lines quickly and efficiently. The ability to move a brigade combat team over 500 miles in a single night fundamentally alters mission planning and execution. Significance: this capability could shift the balance of power in future conflicts, enabling U.S. forces to conduct operations that were previously unfeasible. It emphasizes a strategic shift towards rapid deployment and maneuverability, aligning with modern warfare's demands for flexibility and surprise. 4. Operational integration with joint forces. The FLRAA program is not solely an Army initiative. It also involves collaboration with U.S. Special Operations Command SOCOM and potentially other branches of the military. This cross-branch integration is vital, especially as the Army seeks to ensure that the aircraft meets the needs of a diverse set of operational scenarios, including both conventional and special operations. Significance: the FLRAA's design will influence joint operational capabilities and could lead to new doctrines that promote interoperability among different military branches. This integration is increasingly important in modern warfare, where joint operations are often necessary to achieve strategic objectives. 5. Modularity and future adaptability. While the FLRAA will initially be based on the Bell V-280 Valor, Army officials have indicated that the final production model will undergo modifications. This adaptability demonstrates a commitment to creating a modular platform that can evolve over time based on operational feedback and technological advancements. Significance: the potential for modular upgrades means that the Army can keep the FLRAA relevant in the face of emerging threats and technological innovations. This forward-thinking approach allows for sustained operational effectiveness and reduces the risk of obsolescence. 6. Focus on soldier input and human factors. The Army's emphasis on human factors and soldier input during the design process is a crucial aspect of the FLRAA program. Engaging soldiers in the development stage not only enhances the aircraft's usability but also fosters a sense of ownership and pride among the troops. Significance: incorporating soldier feedback into the design process leads to a more effective and user-friendly aircraft, ultimately improving mission success rates. This approach also strengthens morale and readiness within the ranks as soldiers feel their insights directly contribute to their operational capabilities. Conclusion: the FLRAA program represents a pivotal evolution in U.S. Army aviation driven by technological innovation and strategic foresight. By recognizing the significance of digital engineering, cultural transformation, tactical operations, joint integration, modularity, and soldier engagement, one can appreciate how FLRAA will shape not only the future of Army aviation but also the broader landscape of modern military operations. The success of this program will be foundational in preparing the U.S. Army for the complexities of warfare in the 21st century. Here are the 4 most valuable points for in-depth analysis and discussion regarding the U.S. Future Long-Range Assault Aircraft FLRAA project, emphasizing its historical context, present developments, and future implications. 1. Strategic evolution and technological advancements. The FLRAA program represents a significant evolution in U.S. Army aviation strategy, transitioning from a helicopter-centric force to one that integrates advanced tiltrotor technology. This shift is characterized by the development of the Bell V-280 Valor, which offers enhanced speed, range, and operational capabilities compared to the venerable UH-60 Black Hawk. With a cruise speed of 280 knots and a ferry range of 2,100 nautical miles, the V-280 is poised to revolutionize air assault operations, enabling rapid troop deployment over vast distances, particularly in challenging environments. The emphasis on digital engineering and real-time collaboration in the design process also marks a modern approach to military aircraft development, promising greater efficiency and effectiveness in meeting operational requirements. 2. Operational impact and tactical transformation. FLRAA's capabilities will fundamentally alter U.S. Army operational tactics, allowing for large-scale, long-range air assault L2A2 missions that were previously impractical. The ability to transport a brigade combat team over 500 miles at night enhances the Army's strategic reach and flexibility. As the Army prepares for the integration of FLRAA, it is already experimenting with new tactics and operational concepts, demonstrating a proactive approach to adapting to future combat scenarios. This transformation necessitates not only technological adaptation but also a cultural shift within Army aviation, as pilots and crews must become proficient in higher speed, higher altitude operations, moving away from traditional low-speed, low-altitude flying. 3. Challenges and lessons learned from previous programs. The FLRAA program is not without its challenges, particularly in light of the operational history of the V-22 Osprey, which has faced scrutiny over mechanical issues and safety concerns. The Army's leadership has emphasized the importance of applying lessons learned from the V-22's operational history to ensure the FLRAA's success. This involves addressing design and engineering challenges early in the development process, implementing rigorous testing protocols, and maintaining a focus on affordability, survivability, and reliability. The proactive engagement with Special Operations Command SOCOM to tailor FLRAA's features to operational needs also highlights the importance of inter-service collaboration in developing effective military capabilities. 4. Future implications for Army aviation and joint operations. The introduction of FLRAA is expected to have far-reaching implications not only for Army aviation but also for joint operations across the U.S. military. As FLRAA enhances the Army's ability to conduct rapid air assaults and sustain operations over extended distances, it will also influence how other branches of the military approach air mobility and support. The program's focus on modularity and affordability suggests that FLRAA could become a viable option for international partners, potentially expanding its marketability and enhancing U.S. defense relationships globally. Additionally, the successful integration of FLRAA into the Army's operational framework could serve as a model for future military aircraft programs, showcasing the benefits of adopting innovative engineering practices and collaborative design methodologies. In summary, the FLRAA project symbolizes a pivotal moment in U.S. military aviation, encapsulating technological innovation, operational transformation, and strategic foresight. Its successful implementation will not only enhance the capabilities of the U.S. Army but also influence the broader landscape of military aviation and joint operations in the years to come. 1. The Bell AH-1 Cobra Helicopter Program 1967–1986. The Bell AH-1 Cobra was the first dedicated attack helicopter used by the United States military. Developed during the Vietnam War, it was designed to provide close air support for ground troops. The Cobra introduced the concept of a dedicated attack helicopter, which allowed for greater speed, maneuverability, and firepower compared to traditional helicopters. Its development faced challenges related to the evolving nature of warfare, requiring continuous upgrades and modifications throughout its service life. Similar to the adaptive strategies seen in the FLRAA program. 2. The Sikorsky UH-60 Black Hawk helicopter development 1972 to 1979. The Sikorsky UH-60 Black Hawk was developed in response to a need for a versatile utility helicopter that could perform a variety of missions including troop transport, medical evacuation, and logistics. First entering service in 1979, the Black Hawk has become a cornerstone of U.S. Army aviation, and like the FLRAA, it was intended to replace an aging fleet, in this case the UH-1 Iroquois. The Black Hawk's design evolution over the decades has included numerous upgrades to enhance performance, which parallels the FLRAA's goal of leveraging cutting-edge technology to meet modern warfare requirements. 3. The V-280 Osprey Program 1986-present. The V-280 Osprey, a tiltrotor aircraft developed by Bell Boeing, represents a significant leap in military aviation technology due to its ability to take off and land like a helicopter while flying like a plane. Initially developed in the 1980s, the program faced numerous technical challenges and budget overruns, leading to a protracted development phase that lasted several decades. The Osprey finally entered service in 2007 and has since played a crucial role in various military operations. The experiences and lessons learned from the V-280 program, particularly regarding operational integration and pilot training for tiltrotor aircraft, are expected to inform the development and implementation of the FLRAA. The Future Long-Range Assault Aircraft FLRAA program represents a transformative leap in U.S. Army aviation capabilities, aiming to replace the aging Sikorsky UH-60 Black Hawk helicopter. With a projected service entry in 2030, the FLRAA is poised to enhance operational flexibility, speed, and range, significantly altering the landscape of military aviation. Historical context and current development. Initiated in 2019, the FLRAA project is part of the broader Future Vertical Lift FVL initiative. In December 2022, the Army awarded the contract to Bell Textron for its V-280 Valor tiltrotor design, signaling a pivotal shift in military aviation from traditional helicopters to more versatile and faster aircraft. By August 2024, FLRAA successfully passed Milestone B, entering the Engineering and Manufacturing Development (EMD) phase, which will see the construction of 6 prototypes aimed at demonstrating operational capabilities before the low-rate initial production phase in 2028. Design and operational advantages. The design goals for the FLRAA include unprecedented speed and range, with a maximum cruise speed of 280 knots and a ferry range of 2,100 nautical miles. This is a significant improvement over the Black Hawk, enabling the Army to conduct operations over greater distances and with enhanced efficiency. The FLRAA's tiltrotor design allows for high-speed flight while maintaining vertical takeoff and landing capabilities, creating new operational possibilities for troop transport and combat missions. Cultural and tactical shifts. The introduction of the FLRAA will require a substantial cultural shift within Army aviation. Pilots and crews will need to adapt to new flight dynamics, transitioning from traditional helicopter operations to high-speed altitude-based maneuvers. The Army is already collaborating with Marine Corps aviators to develop training programs that will prepare pilots for the operational environment of the FLRAA. This cultural transformation extends beyond training. It involves rethinking tactics and procedures. The Army is actively engaged in testing new operational concepts such as large-scale long-range air assault, which aims to deploy a Brigade Combat Team over 500 miles in a single night. This capability will not only enhance the Army's strategic reach but will also allow for more effective responses to evolving battlefield dynamics. Future outlook. 1. Technological advancements. The FLRAA is at the forefront of integrating advanced technologies, including digital engineering practices that enhance design efficiency and allow for real-time adjustments during development. This approach is expected to reduce time to field for the aircraft and improve overall performance. 2. Operational integration. As the FLRAA enters service, it will likely be integrated into joint operations alongside other military branches, enhancing inter-service cooperation. This could lead to the development of new joint tactics and operational frameworks that leverage the unique capabilities of the FLRAA. 3. Global market potential. The FLRAA could attract interest from international allies. Similar to the Bell V-280 Osprey's limited foreign sales. Depending on its performance and reliability, the FLRAA has the potential to become a staple of Allied military aviation, particularly among nations seeking advanced rotorcraft capabilities. For challenges and lessons learned, the development of the FLRAA will need to carefully consider the lessons learned from the V-280 Osprey's operational history, particularly concerning maintenance and reliability. Continuous feedback loops from operational users during the development phase will be crucial in ensuring that the FLRAA meets the Army's needs without inheriting past issues. 5. Expanded role in future warfare. The FLRAA is expected to play a critical role in the Army's future operational concepts, supporting a wide range of missions from troop transport to medevac and beyond. Its ability to conduct rapid, long-range assaults will enable the Army to maintain a strategic advantage in potential conflicts. Conclusion. The FLRAA is set to redefine U.S. Army aviation and enhance its operational capabilities in the coming decades. With its advanced speed, range, and versatility, the program not only addresses current operational needs but also prepares the Army for the complexities of future warfare. As the program progresses through its development stages, the Army's commitment to innovation, training, and strategic integration will be key to realizing the full potential of the FLRAA. The successful implementation of this aircraft will mark a significant milestone in military aviation, reshaping how the Army conducts operations for years to come.